Okay, so here we go. So here's what you're going to do. You're going to be given an equation. Right? And you're going to be given an equation, and then you're going to be asked to graph it. Now, as I showed you earlier, there was a bunch of shortcuts on things I showed you. Well, this is the y-intercept. This is, like the slope at the y-intercept. This is going to bend up, bend down. There's a lot of different ways of graphing it. But when you first learned to graph regular and linear equations, you just did old-fashioned t-chart. We're going to do the same thing, and then we're going to learn all the other properties as we go along. So I'll give you something, and I'll give you something like this. I'll give you what points to plug in, but of course later on you're going to have to pick your own points, and there's a right way to choose those x values so that you get the graph. Since it's not a straight line, you can't just pick any points and it'll work. You have to know where that middle part is. And then you're just going to plug them in. Now, this is order of operations, but you have to do it correctly. That's very important. So plug in -3 into here, use parentheses, and go ahead and calculate it. Okay. Go ahead and calculate what that should be. Just using order of operations. Now, what number do you get? Okay. You should get an answer of, try it. -7. So that negative in front makes a difference. So watch closely. So we have this right here is the same as multiplying by -1. The negative in front is like multiplying by -1. So it's important to realize that, so you do exponents first. Right? Then you multiply. So it's really -9 minus 6 plus 8 minus 15 plus 8 is -7. So if we can't do this basic order of operations we learned back in the 7th grade, yeah, it makes it kind of difficult. So just be very careful about this, because they're almost all like this, with a squared, and sometimes they have a negative in front. Okay? So be very careful. Showing all the work will prevent a lot of mistakes as well, so you're going to be asked to do that as well. Okay, so yeah, what you cannot do is just say, well, let's work from left to right, negative and negative is positive, that's multiplication, and then take a exponent. That should be a red flag. The fact that you would multiply and then do an exponent is the wrong direction on order operations. So if you ever see yourself multiplying and then do an exponent, something's probably up. So let's go ahead and calculate. Oh yeah, then we plot the point. So we start at 0, 0 in the middle, and the x value is -3. So remember, negatives are to the left. So you go 1, 2, 3 to the left, and then -7. That means it's down. So you go down 7. Okay. And try another. So go ahead and calculate that. Now, knowing to be careful with the exponents. What value do you get when you evaluate that? Now, show the work like I did on the board, on the whiteboard. Remember, you're going for accuracy, not speed. I don't want you saying, well, he wrote that in 4 steps. I'm going to do it in my head and just hopefully everything works out and I pass algebra. Not a good plan. I do the extra 5 seconds of writing and yes, get 100% on it every single time. Don't use them to rush. So we should get 0. So we get, when we do the exponent here, we get +4 multiplied by -1. That's -4. Here we get negative 4. Negative 4 and negative 4 is negative 8. And then negative 8 plus 8 is 0. Do not start left to right. If you're doing negative times a negative, that's the mistake. Exponents, then multiply, right?
Okay.
Try one more. Try one more, see what you can get that. As soon as we get past this right here, the rest just takes care of itself. It should be no problem. We just have to get past this order of operations business. Okay, should get an answer of 5. So negative 1 squared is 1. Times negative 1 is negative 1. 2 times negative 1 is negative 2. Negative 1, negative 2 is negative 3. Negative 3 plus 8 is 5. Positive 5. There we go. So we can continue this. Plot the points, calculate another, plot the point, calculate another, and continue this. So it's going to be somewhat tedious because it's going to be the same steps repeated over and over. Now you might note that after here, I'm not doing any more calculations, but how do I know where the point should go? I'm just going to put it there. I'm just going to put it there. And I'm just going to put it there. How do I know those last 3 points and where they go without doing a calculation? Okay. And that's one of those properties where you're looking at, well, we don't really need to calculate every single little point. We have this thing called symmetry where with these parabolas that it's an exact mirror image down the middle. So from this special point at the top called the vertex, I know it's a mirror image on both sides. So if I calculate this point over here, I know it's exactly 2 from the middle, or that middle line of symmetry. Well, I know there's another point on the other side exactly 2 away as well, because it's symmetric. Same thing here. I know on the x-axis, well, here's the middle. 1, 2, 3. There's a point 3 to the left, and 1, 2, 3. There's a point 3 to the right. I don't actually have to plug in 4, 5, and 6 to figure that out. So you're going to see that on your homework. So you'll have symmetry on your graph, meaning it'll be like a mirror image shape, symmetric. But then also on your t-charts, you're going to see a lot of the same numbers. If you look at 0 and you look at 2, they both equal 8. If you look at negative 1 and 3, they both equal 5. So on the graph, the same y values, so are they on the t-chart. All right. As always, we're going to get them equal to 0 or y when we do this, but that's going to be the process. Okay. Now, there's going to be a method for picking these values, and we always want the middle of the graph to be the middle of our t-chart. So I'm going to show you tomorrow. How can we figure out what this middle vertex is? It's at negative 1. X equals negative 1. Right? Here's 0. 1 to the left is negative 1. So how would I know before I actually start plugging in points that that's where I should start? That's the middle of my graph, and it should be the middle of my t-charts. So I see here, so you get negative 4. And if I go 1 up and 1 down, you see how it's the same number? Because right here, negative 3, that's at negative 3. Same thing if I go up 2, it's at 0. If I go down 2, that's at 0. So you see this is at 0, this is at 0. How do we figure that out? How do we know that middle point before we even start? So we'll look at that tomorrow and figure that out. Okay. But for now, let's be plugging in points and expect to see a lot of symmetry in the graphs and your t-charts. So really the skill here is pre-algebra. Just do exponents before you multiply. You'll be fine. Show all the work as well to avoid little mistakes. Here's what I'm going to pass out to you right now. Now these are actually from the book, so even though it's a worksheet technically, but they're the exact same problems from the book, so you can go to 9-1 and check your answers, at least the odds. If you know 4, 5, 6, 7, 8. 5, 2, 4, 6, 7. Almost. Found it? Here we go. So let's look at the layout here. You have 6 problems, 2 on each side of the paper. I give you the equation. I give you a t-chart to fill out. I give you all the x values you need to plug in. And I show you a template on how to show your work for each problem. So for each of these, you're going to do a separate little calculation, right, for each one. So for every x, I'm going to plug in this value. I want to show my work. So I'm going to say equals -3 squared is 9. Bring down to -3. And 9 minus 3 is 6. Okay. Go back up here. Plug in my answer. So I got to graph the point -3, 6, right? So I'm going to go over here. So -3 is 3 to the left. 1, 2, 3. Positive 6 is 6 up. 1, 2, 3, 4, 5, 6. Okay. Put a dot. And repeat. So I'm going to plug in -2. I'm going to show this calculation. -2 squared is 4. Bring down to -3. And we have an answer of 1. So I got to graph -2, 1. One minus 3 is -2. We have -1 right here. -2 is 2 down. And you'll eventually see the parabola forming. You might notice that that last number is still the y-intercept. Just like it was with linear equations, this last number, when there's a number on the end, it's still a y-intercept like it's always been. So some familiarity. -2. And once you make it to the vertex, you'll see it starts moving back up, and you start seeing some of the same numbers. All right, 1. So we have -2, +2, 1. 2 and 1. Right? And just like I did on the PowerPoint earlier, is that we have this middle line where it's symmetric. So I might have this point over here. I could plug in 3, and I can figure it out, but I also have this idea that, well, it's going to be the same distance. So if this is 1, 2, 3 away from the middle, there's going to be another point 1, 2, 3 away from the middle as well. I don't necessarily have to plug in 3 and do the same calculation to figure that out. I know it's going to be the same. So if these are going to be both -2, these are going to be both 1. I know without doing a whole lot of extra work that, yeah, by looking at the graph and just trying to make it even on both sides, I know it's going to be symmetric. Hopefully you'll draw it a little bit better than mine. Again, this shape is called a parabola. Let me redraw a shape that's not a parabola. So if you would do it, this would be a wrong. Don't do this. So what's wrong about this? It's two things. Number one, right here, it's going straight up and down. It can never go straight up and down. Graphs will not be functions anymore if they're going straight up and down. Also down here, it looks more like a V, like a point, which it should not. Okay. So you always want to make the graph going slightly outward. It's more of a curve at the bottom. It's not exactly straight. Okay. There is a curve to it always. But it's never straight up and down. It's always going out to the sides a little bit. Okay. Now, I'm going to demonstrate something on the next graph. Don't write it down, but just watch. When you're doing linear equations, this might have happened. You plug in points, you get this, you get this, you get this, then you get something over here, and you get this, and you get this. What does this mean? What does this mean if you're graphing a straight line and this happened? What do you think? What does this mean? Is it right? No. So, just like with a straight line, you wouldn't just say, oh, I graphed it, okay, here's my straight line, right? Which you do see people do. They're missing the big picture, though. So if you have a point and it doesn't fit the rest of the pattern, that means this is a wrong answer. So that means in your calculation you did something wrong. You go back and redo it until the shape is the right shape, a straight line. So you'll have the same thing here with your parabolas. You might miss a calculation or two. So if you get something like this, don't just go like this and say, oh, I guess it goes over this way and hooks on back, and that one just looks different from everything else. No, that means you made a mistake on that one point, right? Go back and fix it. All right. Please show all your work just like this. Oh, not like that. If you don't show your work, it will not be counted. This is how your work should look on all of your problems. Take a look at it. That's exactly what your work should look like. If you don't show the work, I will let you have to keep it and finish it. Yeah, do all the problems, all 6 of them.
I finished 2 of the